Okay, so good afternoon, everyone. So today we are going to do the question for lab week 3. So the purpose of this question will show you that, why we study LU factorization, because at the end of this lab exercise, you will see the purpose why we have to study LU factorization, okay? So what is the problem? So the problem is we have to solve the system a to the power of m x equal b, okay? And we do not want to solve it by raised to the power m of the matrix A before you solve it, because it's very costly to do that. So instead, we will do iterative algorithm like this. Okay, so first you define x0 to be equal b, and after that you solve ix1 equal x0, x2 equal x1, and so on. Okay, so let me show you why it works. Yeah. So first, let me show you why it works. So just take a simple example. So now suppose, well, maybe let me make a new script as well. Yeah. So because this one eventually we have to make a new script. So let me share the. So you see, the idea is you try to solve a to the power of m x equal b, yeah, by the algorithm, by set x0 equal b, okay, and then a x1 equal x0, a x2, I mean solvent, yeah, so this one is solved. Okay? A x1 equal x0, a x2 equal x1, and so on, yeah, until you got to axm equal xm minus 1. Okay, I just write like this. So xm minus 1. So maybe underscore for the subscript. So underscore for the subscript, yeah. Okay, so let's see why it works, yeah. So now suppose I take m just equal 3. Okay, so suppose you take m equal 3. So just take m equal 3, yeah, for example. So this one is a simple example to see how it works, yeah. So suppose you have x0 equal b, okay. So then if I follow the algorithm, so I need to solve a x1 equal x0, a x2 equal x1, and then a x3 equal x2, right? And I stop because the algorithm said that I have to do only m linear system. Okay, so m equal 3, so I stop here. And now my claim is x3 is the solution. Okay, so claim that x3 is the solution of a to the power of 3 times x equal b. Okay, so that's my claim. I mean, just a simple claim. Right? And why is that? Okay, so now I will prove it. So I prove the claim, yeah. So you see that we start with the n. So ax3 equal x2, right? So that is the last equation. And now if I multiply by a, On the left, well, maybe I start with this equation, yeah. Then I start multiply a on the left, then I got a times x3 equal x2, right? And then I do it one more time. So no, sorry, I missed the ix2 here because I multiply on the left and on the right by matrix A. Okay, so so then now what is ix2? So if you look back of this line, then ix2 actually equal x1. Okay, and now you do it again. So now if I multiply a on the left and a on the right, you know, so I have a times 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 x3, yeah. Then on the right, okay, I skip the middle one. I don't need the middle one anymore. So I have a times x1, right? And what is a times x1? So if you go back to this, then a times x1 is just equal x0. Okay, so you see it, so equal x0. And if you look at the very last line, this one just showed you that a to the power 3 of x3 equal x0 and x0 just equal b. So essentially x3 is just a solution of a to the power 3x equal b. So you see, if you have a power m is 100, you just do it like this, you know, 100 times. So you don't have to compute the power a to the m of the matrix. Yeah. So that is the idea. So we will solve this a to the m of x equal b by two methods: LU factorization and backslash commands. So the backslash command is just the Gaussian elimination. Okay. Okay. So now, well, we have to save it. So save it. So run LU solve, right? Run LU solve. Okay. So we save it as a script. So now first you have to download the LU solve from Moodle. So this one, you know, in the same directory where you. So now go back to the question, yeah. So the question is first you have to download this LU solve for Moodle. So this one in the same directory that you find this exercise, yeah. And after that, you have to read and understand how LU solve works, okay. So now we go back to MATLAB and let me share you my screen. So see, in my directory now I have LU solve. Okay, so now I just edit LU solve, or maybe helps LU solve plus, yeah. Okay, so you see that LU solve is just solving AX equal B by LU factorization. So assume that you have LU factorization from the previous command, right? Then you solve AX equal B by solving two linear system, you know. So by solving Ly equal PB and Ux equal Y. So let me make an example. Suppose I have a matrix A, okay, is a very simple matrix, say 3, maybe 1, 2, 3, 3, 2, 1, 4, 5, 6, yeah. And now I suppose I have a matrix B, yeah, equal 1, 2, 3. Okay. Now I want to solve ax equal b, so I just use backslash command. Okay, so suppose I have something like this. Now I can solve by the LU solve command. So I will do the same. So I will say that, well, first I have to compute the LU factorization of the matrix A, right? So I just use the command LU. So if you look at the command LU, you will see that help LU, you will see how to use it. So I just produce the LU factorization for you, yeah? So LU P equal LU of A. So LU P equal LU of A. Okay, so the matrix L look like this. So it's a lower unit triangular matrix, and the matrix P upper triangular matrix like this. Okay, and P is a permutation matrix. So you see that you swap row 1 and row 3. So now I will solve the linear system by LU solve, right? So remember, LU solve, you just put in LUP, yeah, so LUP and the right hand side. So the right hand side just B. And you see X1 and X2, they're identical. Okay, so LU solve is just another way to solve the linear system. Assume that you have the LU factorization of the matrix. Okay, so far so good. Any questions so far? So if you look inside LU solve, you know, you will see something like solvent Ly equal PB and solvent Ux equal Y, but we don't have to look into it. So we just need to know how to use it, you know, for the moment. Yeah, so far so good. Yeah. So now we go back to the main program. Yeah, the main question is, so we cover 1 and 2, right? So we understand how LU solve works. Yeah. And then now what we need to do is we have to write a script, you know, run LU solve to do the task that eventually will solve this AM X equal B. So we do step by step, yeah? So prompt the user to enter the value of N. Okay, so how do you do that? So now let me stop sharing my command windows. I share my edit windows, yeah. And you can see that I just cut and paste the question here. So how do we do that? Well, so you can use the command called input, yes. Okay, so we just say N is input, enter the value, enter the size of matrix A, okay, and equal something, okay. Then ask the user to enter the value, okay. So you can run it. And then, you know, after that, the next question is, similarly, you can ask the user to enter the power of the matrix. Yeah. So you can you can do the same in the power A to the M. Yeah. So you can say that, okay, M is input of, or enter the power M Okay, so m equals something. Okay, so that is the enter m and n. And the next question is use the MATLAB command ran in order to generate a random square matrix of size n times n. So how do we do that? So let me cut the question in. So how do we use the run command to generate a random square matrix of size n times n? So what is the correct command? Anyone? Well, the command is given. So ran, yeah? So how do you use it? Well, we can try, yeah? So we can try how to use, so let me go to the command windows and then you can see, okay, so suppose I clear everything, yeah? So clear. So you can play around with ran, yeah? First, you can say help ran, yeah? And you can see that ran and return an n by n matrix containing random values, okay, pseudo random values. And if you give two numbers, then it returns an m by n matrix. So what is the correct command now? You know, so you can play, say, ran of, say, 3, that will return 3 by 3 matrix. Yes, but you see, I mean, here, because it's a square matrix, you need to give only one number. You can do it, you can do like this, but it's just the same. Yeah, I mean, yes, essentially in the square matrix, we just need to put in one number. You can put in two numbers at the same size, but we don't have to do it. Okay, so go back to my editors. Yeah, then I say that I'm going to write a equal ran of n. Yeah, and I don't want to display the whole matrix. It could be 1,000 by 1,000 matrix, could be very lengthy. So I just suppress the output by this semicolon. Okay. And now how do I add n to the diagonal entries of A? So at least I know 3 ways to do it. Yes, you can use diagonal, but you see, if you say, so let me share my my command windows. Yeah, so you can use diagonal. Yeah, but if so you still see my command windows. Yeah, okay. So now clear. So you see, if you say diagonal, say 3, then just give you only 3 like this. So what you need to do is you need to give a diagonal of a vectors. Yeah, so vector say 1 to 3. Then it gives you identity matrix like this. Okay. But then, you know, you need to multiply by n. So in this case is 3. Yeah. Then it gives you this matrix. Then you should add this one into the matrix A. Okay. Another way is there's a command called I. So this one gives you identity matrix. Yeah. And if you multiply 3 with the identity matrix, you got the same thing. So at least 2 ways. Yeah, you can use diagonal. But diagonals, then you have to supply vectors, not only single number. But for command I, you just supply a single number, then it gives you a diagonal matrix. Okay, and then you just multiply by n. So whatever ways you choose, yeah. So let's see, I go back to my editor. So I say that I will use the Now, A equal A plus N times IN. Okay, so another way is A equal plus diagonal N times 1 N. So it's a bit longer, okay? So that is the question D, okay? So now the next question is give you the full answer already here. So if you look at the next question, so go back to my editor. So you see, actually this one you just cut and paste the command, yeah. So the time use is L1 minus L0. So this one is the time use, yeah. So you just put in the use time is just D1 minus D0. So just give you all the commands already. Okay. So CPU time, okay, it just take in the clock inside your desktop or laptop or any device, yeah. Question. So what is the difference between, good question. Well, I don't know, we have to try, yeah. So if suppose you put in diagonal of 1, 3, 1, so this is a column vectors and you get this. And if you put in a row vectors, you get the same, yeah. So does it answer your question? You get the same. So you can put in a row or column vectors, yeah. Yeah, I mean, if you don't know, just put it in, okay, and try it, okay. And now, now the next question is about CPU time, yeah. So CPU time, if you put it in like this, so every time you enter CPU time, it gives you a different number, okay. So there's a clock inside your computer, inside your CPU, and every time you call CPU time, then it just read it off from there, and you see, if you take the difference between the two numbers, then it gives you the time that has passed, you know. So this one is like this, yeah. And you can say help CPU time. Okay, so return the CPU time in seconds that have been used by MATLAB since MATLAB started. Okay, so CPU time, you do something here. Well, you remember the timestamp, right? You do something, then you call CPU time, then you minus the timestamp, then it returns the CPU time you have used. Okay, so that is the question. And so this is what I have, yeah. So this is what I have so far. And now you can run it. You know, you can run it to see what is going on. So if I run it, yeah, I can show you my command windows. But essentially, just enter the matrix of 100. So say 100 here. So power 10, and that's it. So I just make a matrix A the size 100 by 100 and use time, so 0.105 seconds. Okay. So far so good, right? So you got N, you got M, and you can see the matrix A could be very big. Okay, so that is what has been achieved. So now go back to the question again. So we've been up to part E, yeah? Part F. So part F, now you just use random again, but now you need to generate a vector of one dimension. Sorry, n by one, n rows by one, yeah? So n by one vectors. Okay, so this one you have to give two numbers. Okay, and the next one, so now the next one is a bit lengthy, so cut and paste into MATLAB. Yeah, my use time is, well, depends on your computer. It should not be the same. It should not be the same on my computer and your computer, okay? Well, your zero spin that you have a better computer than me. Well, and then actually there is on some computer, the CPU time doesn't work as well. So either case, okay? But let we move on to the next question first because it's a bit lengthy. So now we have to write a loop, okay? And in the loop, you have to do two things. You have to compute the so this one is defined. Okay, so now let me do it step by step, yeah? So first we have to write a loop to implement the algorithm. So it should be a loop like this, yeah? So K is 1 to M. So remember the algorithm, so we have to do this M times, yeah? So inside the loop, you have to solve M linear system. Okay, so inside the loop, so you have to solve ax equal ax k minus 1 xk, yeah, equal x k minus 1. Okay, so how do we do it? Well, remember first you have to set x0 equal b. Yeah. Okay. And now how do you solve it? So, you know, you have to solve, at least you use two methods. Okay, so first method is by LU factorization or by LU solve. Yeah. And then the second method is you solve AY K equal Y K minus 1 by backslash command. Yeah, by backslash. Okay, so how do we implement this? And Y0 equal B as well. Because X0, Y0 are the same. Yeah. So how do we implement this? So remember, for LU solve, you have to put in the LUP, right? So first you call LU solve, right? Okay. And now what do you put in? So there's a hint here. At least for my computer, I can have LUP here. And now what is the next? So what is the next input? And then what is the output of this? Well, I mean, if you look at this, you know, I mean, the right-hand side is x k minus 1, right? And then the left-hand side should be xk, right? Yeah. Robert Z, I mean, the problem is MATLAB. I mean, this is not a correct syntax if you run it, it will report some errors. Yeah. And then, so how do you do it? How do you fix it? And then you want to reduce the variables as well. I mean, you can have x1, x2 up to xm, you know, but m could be 1,000, and it would be a waste of memory. You know, what you need is only x xm, the very end, you know, x3 in this case. Yeah. So how do you write down here? So what is the correct command here? I put in question mark. It means that I'm not sure. Yeah. So what is the correct command to put in? Anyone? Have you typed in the commands? And similarly, we down here we have yk equal a backslash yk minus 1 as well. Yeah, but however, this one is question mark, yeah, because we don't know. I mean, it might not be the correct way. So how do I fix those two commands? Maybe you solve first. What should I put in here? So look, there's a hint here. You don't have to define the array y1, y2 up to ym, right? In MATLAB, you can do y backslash y, so that the old entries in y will be overwritten by the new values. Okay, so that's a hint. So it means that here I can reuse my variable y. You know, I mean, but then initially it means that I don't need y0 anymore. I just set y equal b. So y get reused again and again. So y0 equal b. And then y0 get in here to complete y1. And then, you know, you go up here, go down to the loop. And then y1 get in here to complete y2 and so on. So at the end of the loops, then you just have ym in the vector y. Yeah. So this one, we just follow the hints. Yeah. And so now how do we use the hint to fix the x? Are you still with me or you went away already? I still see many people here, but so anyone, have you tried? So this is a bit tricky. Yes, it says error for that line because I put question mark here. That's why I want you to fix it. How do you fix that? How do you fix this line so that, you know, using the same philosophy, you know, I mean here, y equal a backslash y, yeah, so you get reuse the vector y again and again, you know, so this one you do the same. So how do you do that? Yeah, exactly. Now you just remove the subscript, yeah, and you just use the vector x again and again. Okay, so initially x equal b, so it means x0. And then, you know, you solve it again and again, okay? Yeah, so you save it. And now, you know, what we need to do is we have to compute the LU time. Okay, so now you compute the LU time. So before we have we should have a LU time equal. Okay, so because LU time, you know, you have to count the time it used to compute the LU factorization as well. Initially, it has to be use time, yeah. So counting the time to compute the LU factorization, yeah. But the ML time can be set to be 0. So ML time is the time for backslash command, yeah. So total time using backslash command, yeah. Okay, and now, you know, you need to add up. So here you put T0 equals CPU time. You perform the LU solve, right? So you call T1 equals CPU time again. And then you add up LU time. You add LU time plus, you know, the time you just spend to solve. You know, so we add the time used by LU solve, yeah. Okay, and you do the same for the backslash command. So maybe this one should have a separate line so that you can see it. So you do the same here. So you say that, okay, so T0, so remember the same method. So you call CPU time. And then you call T1 is CPU time. Then ML time is ML time plus T1 minus T0. So this one is you just add the time used by M backslash, yeah. So you see, initially ML time equals 0, but then every time you use this command, you just compute the time and you add it up. So after the loops, at the total time, you know, used by the loops, okay? And now, what is the next question? So the next question is check whether the both methods give the same answer, okay? So, and there's a hint. So, and then you print on the screen. So now the next question is check whether both methods give you the same answer. Okay, so now you have to read the hint, yeah? So the hint is, and again, you can run anytime to check whether your program is correct or not, okay? So right now, suppose I run it, so n is 100, m equals 3, so everything is okay, okay? So there is no syntax errors. So now how do I check it, okay? So the hint is you use the command, look the command, so norm v infinity computes the infinity norm. Okay, so this one you need to compute the norm of the errors between x and y. Then less than or equal 50 epsilon. So this is a machine for epsilon, yeah. So 2 times 2, sorry, 2.2 10 times 10 times 10 to the minus 16, yeah. And this one just a norm of infinity norm of x and norm infinity of y. Okay? So we can follow the we can follow exactly the same formula. So let me cut and paste the formula here. It's just not It's not very good. So maybe I just complete the norm. So norm, I got it norm x, yeah. So norm x, yeah. Just norm of x infinity norm. So this one is just the norm of the vector x infinity norm. Norm y. This one is norm of the vector y infinity norm. Yeah. And now I just compare the area. So norm of x minus y infinity norm less than or equal 50 times epsilon. So epsilon times max of norm x, norm y. Okay. Then I just print out. So f print f. So f print f is the command to print out the message. So both methods give equal solution. Okay, so you can print out this message. Else, okay, so now if this condition doesn't satisfy, then you print another message called two methods give different solution. Okay, so you use fprintf as well. So fprintf, two methods give different solutions. Okay. Okay, so now let's see whether it works. Yeah, so now let me run it so I can show you how it works on my screen. Yeah, at least on my machine. Yeah, so let me stop this for a moment, and so far to see whether it is correct. So I type run lu solve. Okay, so I put in say 200. The power is 10. So both methods give equal solution. So far so good, right? So say 300. So power is say 30. So both methods give equal solution. So far so good, yeah. And now, what is the next question? So the next question is, so everything is okay so far, right? Yeah. So now the next question is, print out the screen, LU time and ML time, print in a nice format. So if I put in my editor, should be, so print out on the screen LU time and ML time. So now you just, print out the two variables. So remember we have LU time and ML time. So we call f print f, yeah, and we want to print out a nice sentence that exactly like in the problem. So I cut and paste here. Okay, and let me cut and paste another two lines as well. Okay, so f print f. But you see, so what's the problem with this three statement? So what is the problem here? So if you run it, you know, you get the message n equal 2000, m equal 20 all the times, you know. So it's not what you want, right? Because people can enter different values of n and m. Yeah. So you don't want this, yeah. So how do we fix that? Well, you need to assign number to them, yeah. So what I want is I will replace, you know, n by a percent %d. So percent %d means that a decimal number. Then after the comma, I just put in n and m, okay? So what it say is whenever it print out this, yeah, then it will read off the value of n and it print out here. And every time it get the value of m, then it get the value here and print out the decimal number. Okay, so the same thing here as well. So here, then I will say that, okay, I want to print out floating number, and that floating number corresponding to LU time. Yeah? And here, I put in a percent %f of floating number, and this is ML time. Okay, and that's it. So that is the program. Okay, so now let me run it. So now let me run it. Yeah, so I stop the editor and I go to my command windows, and I hope you have typed it up as well. So type it up and you will see it. Okay, so now we run LU solve. Yeah, so now suppose I put 200. So 30 here. Oh, so we didn't have a new line here. So I have to go back and fix it because we don't want to print in the same line. Yeah, so let me go back. And fix by putting \n. So it means that you have to go to a new line. Yeah. So \n. Okay, so now I'm going back to my command windows, yeah. And then I run again. Okay, so run LU solve, okay. So 330. Okay, you can see that now print out nicely. So n equal 300, m is 30. LU solve 0.04 seconds. And when you use backslash, I think there's a typo here, back BACK. Huh? So BACK. Okay. So let me run it again. I'll save it first. Yeah. Okay, so run it again. So what is the question asking? So maybe 2020. So 2020. So 2020. Okay, so now it's take a bit longer. Okay, so you see that LU solve is always faster than the backslash command. You see, you can try to play with that. Well, I mean, you have to put n is 1,000 or something, because if you put too small number, then, you know, I mean, maybe LU factorization doesn't help. Okay, but if you put in n big, like 1,000, or in this case 300, yeah, and you see the LU factorization is faster. And that is the reason we study LU factorization. Okay. So any more question on this? And then the next question just asks you, okay, so what is the memory MATLAB needs to store the 4,000 by 4,000 real matrix? So how do you do that? So how much memory, how many bytes? Okay, to store well, one entries is 8 bytes, yeah. But now suppose the matrix has 4,000 by 4,000 entries. Okay, so suppose the matrix is, yeah, exactly, yeah. So if you have, say, suppose I put in random 4,000. Okay, so then I can check that. Okay, so I'll take a multiplied by 4,000 square. Then I got about 128 million bytes. Yeah, and if I use the command whos, then it exactly gives me that number. Okay, in terms of bytes. Yeah. So when you store a matrix in MATLAB, the default is stored at a double precision, and double precision, each entry takes 8 bytes. So 8 by 64 bits. Okay. So that's about it. And you can, well, how about complex matrix? Well, complex matrix, then you have to double the size. Yeah. So what about complex 2,000 by 2,000? So if you have a complex matrix, so random 2,000 plus I random 2,000, yeah. Oh, we have 2,000 here. Oh, I should not print it. So I should suppress the output, yeah. But you see now, if a matrix is a complex matrix, yeah, so matrix C here, then it will be, so in this case, it's like 2,000 square, right? Multiplied by 8, and then you have to multiply by 2 because it store the the real and imaginary parts separately, and each one is in double precision. Okay, so that is about it. So any more question?